And now for our third video, we're looking at simplifying this expression with radicals in it. And we have the quantity square root of 2 plus square root of 12, quantity squared. This is going to work essentially the exact same way as the last example where we had another quantity with radicals squared. So yeah, let's see how this all works out. It's going to work out very much the same way. So let's see here. First thing we note is that we have the squared. All that means is that we're going to be writing this thing twice and then having to FOIL it. So this gives us square root of 2 plus square root of 12 times square root of 2 plus square root of 12. And now we use the same old foiling method that we've used probably a bajillion times at this point. So we're going to take this root 2, and we're going to multiply it to this root 2. And we're going to take this root 2, and we're going to multiply it to this root 12, and add those together. Just basic foiling. I like to have these little weird arcs that helps me keep my work straight here. All right, so we have root 2 times root 2. And then we're going to add that to root 2 times 12, or root 12, rather. So we have root 2 times root 12. If you want, you can combine in this step if you can see ahead, but I recommend doing it just this way, leaving it without simplification while you're foiling, just so you can keep your work straight. That way you're not combining prematurely and simplifying things that shouldn't be simplified. Just keeps things nice and neat. So you have root 12 times root 2 and root 12 times root 12. So we have root 12 times root 2 plus root 12 times root 12. Okay, now we can simplify. Since we've done all the foiling, trying to keep all of our work straight without simplifying in this step, now we can simplify. Root 2 times root 2 becomes root 2 squared, or 2 squared root and square rooted. So at this point, we're just using the product rule for radical expressions. This gives us square root of 2 squared plus square root of 2 times 12. So we're just combining this, putting it all under one roof using the product rule. Similarly here we have root 12 times root 2. That's the same thing as radical 2 times 12. And then the last term we have radical 12 times radical 12. That's just 12 squared and then square rooted. Okay, so simplifying as we in any way we possibly can, we have 2 squared, square rooted, that's just 2. And we also have a 12 squared, square rooted, that's just 12. All right, now these guys, I have 2 of the same thing, and 12, thankfully, breaks down. So we can actually use a factor tree here in this case. 12 breaks down into 6 and 2, and 6 breaks down into 2 times 3. So we have a pair of 2's here that we can use. And that's really helpful because now if I rewrite this, I have 2 times 2 squared times 3 plus the same thing over here because it's the same. So we have 2 times 2 squared times 3. Okay. Now using the product rule, I can cancel out this 2 squared part here, but I can't cancel out this extra 2 and this extra 3. So we're stuck with a radical on both of these guys. However, I do get to cancel this. So combining this, yes, I could add the 2 to the 12, but I'm going to save that for another step. So I have root 2 times root 2 squared. Well, that's just 2 times root 3. All I'm doing is employing the product rule. Then we get the same thing over here. Plus 12. All right, now let's combine some like terms here. I have 2 and 12. Those add together to give me 14. And I also have this 2 in the middle, just to illustrate how this all broke down. I'm going to pull that out in front, and I'm also going to combine this radical 2 and the radical 3 so that they're under one roof. So I have 2 times radical 2 times 3. Okay, so all I did was just combine these two guys, put them back under one roof, and move the 2 out in front. You can do that because everything in here is just being multiplied. Perfectly reasonable and rational to do that. Okay? So here we have the same thing, 2 times square root of 2 times 3, and we already added the 12 to the 2, so we're in good shape here. The 2 and the 3 can't break down anymore, so we're left with just a root 6 inside each of these guys. Okay, so we have 14. I want to combine like terms, so I have 2 of these root 6's, and I have 2 of these root 6's over here. So how many root 6's do I have in total? The answer is 4. So I have 4 square root of 6's. And at this point, I'd say that this is pretty much simplified. Sure, you could factor out a 2 out of each of these terms here, because I have a 4 and a 14, but I don't think I'm going to do that. I think I'll leave it as is, because this is really nice and neat. So with that, this example is done. And if you found it helpful, as usual, please smash that like button. And if you want to see more examples beyond this one, please hit up Project Greater Ed. You can find the link in the description below. Thanks, and I'll see you there.